When I was a kid, I used to love watching old reruns of Bugs Bunny. I mean, these are cartoons that are like from the 1950s. I don't know if you guys even know who Bugs Bunny is anymore, but he's this little, basically smart aleck rabbit who always is just kind of a jerk, but it's fun. Anyway, so I used to love watching these, and one of my favorite episodes is one I always think about when I think about the speed of light. And I just wanted to show you the quick clip. So in this episode, Christopher Columbus is setting out to prove that the Earth is round, and no one believes him, of course, despite we know that everybody knew that in ancient times. Bugs Bunny's like, hey, man, I can prove that the Earth is round. Let me show you. And he throws this baseball all the way around the Earth. I just want to show you the scene really quick.
Don't let your spaghetti boil over, Chris. I'll prove it for you.
How you gonna prove?
I'll show you.
All right, I just love that. I love it's got all the stickers on it. And it's just a stupid little thing. But the beauty here is, okay, he throws this ball and it goes all the way around the Earth. I just want to use that to illustrate the incredible speed of light. All right? If you could do that with a baseball, just throw it all the way around the Earth, light is so fast that it would go all the way around the Earth 7 times in just 1 second. In 1 second. Light is just so insanely fast. It travels 186,000 miles every second. Now, despite that enormous speed, truly enormous speed, almost unfathomable, I mean, it is the ultimate speed limit of the universe. Nothing, science has shown, physics has shown, even in a theoretical sense, nothing can travel faster than that. But even at that incredible speed, the universe is so big that it takes light a really long time to get places. It's truly incredible, and what that implies is this amazing thing that we call look-back time. Now, when you and I are looking at each other in everyday life, right, which we don't do because we're in an online class, but if we did, let's just say we're sitting in a room. When I look at you, I'm seeing light that bounces off your face and comes to me, and since light travels so fast, that light gets to me in like a billionth of a second, right? So when I get the light, it's only a billionth of a second old. And you don't change that much in a billionth of a second. So I'm pretty much seeing things in real time. But when I'm looking at things in the sky, they're so far away, light takes a long time. So let's just say in the daytime, right? I'm looking at the sun. When I look at the sun, it's 93 million miles away. And that huge distance means that light takes about 8 minutes to get to us from the sun. So when you look at the sun, you're actually seeing the light that left it 8 minutes ago. Which, again, doesn't matter all that much because the sun doesn't change a whole lot in 8 minutes. But if it were to just suddenly explode or implode or something like that, we actually wouldn't see that happen for 8 minutes. So it's as if we're looking back in time 8 minutes when we look at the sun. But it gets really cool when we look at the night sky. So I'm just going to, this is Michigan tonight or a couple weeks ago for me, and here's what the sky looks like. And so here's some bright stars that are up, and I just want to illustrate this is so crazy. So here's the moon. When we look at the moon, of course, the moon is much closer than the sun, so the light only takes 2 seconds to get from the moon to us. Just think about that for a second, right? When astronauts went to the moon, it took them like 3 days to get there, traveling faster than any human had ever traveled before, right? But light can get there in 2 seconds. So we're seeing the moon 2 seconds old. Not a big deal. Now, here's Jupiter. The planet Jupiter, at this time of year and where it's located, is about 5 AU away. That's about 40 light minutes, we would say. All right, so it's the light from Jupiter, if you're looking at it through a telescope, would take 40 minutes to get to us. So you're looking back in time at Jupiter about 40 minutes. Not a big deal. However, when we have a satellite in orbit around Jupiter, if we ever sent astronauts out towards Jupiter, the signals, right, the radio signals take 40 minutes to get out there and 40 minutes to get back. So just imagine talking to somebody on Jupiter. You're like, hey man, take a picture of that crazy cloud. 40 minutes later, he gets the signal, and then he sends one back. So 80 minutes after you initially said that, you hear back, he's like, okay, no problem. You know, I mean, imagine trying to communicate that way. That's what NASA scientists face currently as they're communicating with satellites out there. They have to send out like a whole instructions for a whole day because they just can't get feedback that quickly. Even driving the Mars rovers, there's a delay of like 20 minutes, so they have to program the rover for the whole day. They can't just like be driving it with a wheel in real time because of the delay. Now that's it's amazing, but it's still not as amazing as it gets. One of the closest stars to us in the sky, actually it's not the closest, but it's the closest in this view, is this bright star called Sirius. Sirius is 8.6 light years away. So a light year is the distance that light would travel in an entire year. All right, and that translates to about 6 trillion miles. It's an unfathomable amount of miles, right? But when we look at Sirius, it's only 8 light years away. We're actually seeing Sirius as it looks 8 years ago, because the light takes 8 years to get to us. So this light has just been traveling for 8 years, and then suddenly gets to Earth, and we detect it. So we're looking, in a sense, back in time, right, to see what Sirius looked like 8 years ago. Now let's look at another star, Betelgeuse. Betelgeuse is 430 light years away. So even though these look like they're the same in our sky, we're actually looking further back in time as we look at Betelgeuse. We're looking 400 years into the past, right? So what is that? I mean, it's like the 1600s. That's when the light left Betelgeuse, and we're seeing back in time. So when I picture the night sky, and when I look at the night sky, sometimes I just imagine a little date next to every one of these stars, right? That tells me the year of the light that I'm looking at, right? I look at Jupiter, it's fairly recent. I look at Sirius, it's maybe only 4 years ago. I look at Betelgeuse, it's the 1600s. Right? Let's see what Rigel is. That's 780 light years away. Right? This is like before Galileo, all that. So this is like coming from like the 1300s or 1200s. It's crazy. We're looking back in time at these, even the brightest stars in our sky. We're looking back in time. Now, it gets even crazier when we start thinking about looking at other galaxies. So the closest galaxy to us is the Milky Way galaxy. And I'm just going to go zoom in on it. I'm sorry. We're in the Milky Way galaxy. The closest galaxy to us is the Andromeda galaxy. And so here's the Andromeda galaxy. I'm going to zoom in on it. And if you've ever been fortunate enough to look at the Andromeda galaxy through a telescope, it doesn't look quite like this. This is like what a picture would look like. But you'd see a fuzzy glow, like a white glowing cloud. This is the closest galaxy to ours. And it is 2.3 million light years away. So when we look at the light from the Andromeda galaxy, it's been traveling to us for 2 million years. It means we're literally, and you can actually see the Andromeda galaxy with your naked eye, just with your eyes, if you know where to look, and you look really carefully, you can kind of see it. That means you're seeing light with your eyes that's been traveling for 2 million years. It's really absolutely incredible. It's really incredible. And that's just the closest galaxy, right? When we look at some of the farthest galaxies with our telescopes, we're looking back in time literally to a time before the Earth even existed and to the very beginning of the universe. So the sky, because of the speed of light, the sky truly is a time machine. We can see back in time, and the farther we look in deep space, the further back in time we're looking. It's really absolutely incredible.